Okay, here is another problem that represents another problem type from this section. There's a little bit more going on in this problem than in the previous couple. So the new twist here, number one, is that we're given 3 curves here that are bounding our region, not just 2. And then maybe more importantly, we're not actually told what's the interval that we're trying to find the area between these curves over. We actually have to figure that out ourselves. And so what we're going to do is that we're going to have to draw a picture of these 3 curves, and then we should be able to, from that, figure out what exactly is the interval we're going to be integrating over, and what's the interval we're going to be integrating over. And as it turns out, it's actually going to take us a couple of integrals to do that. So the most important first thing here is that we want to draw a picture. We stand basically no chance of getting this problem right if we don't draw a picture here. So y is equal to x. Okay, and that's going to be a line with slope plus 1 that goes through the origin. Y is equal to 8x. That is going to be a much steeper line, a line with slope positive 8, but it also goes through the origin. And then finally, y is equal to 8 over x squared. That is going to look something like this. So maybe it's actually a little bit steeper than what I've drawn, but it illustrates the purpose here for what's going on. So what do we're looking for the region inside of these 3, that's bounded by these 3 curves. So it's this kind of triangle region here that has this as a side, this as a side. That's a curved side, so it's not actually a triangle, but this roughly triangular shaped region is the region that we're going to be trying to find the area of. And so how do we do this? Well, we're going to have to chop the region into 2 chunks. So from here to here, on this interval, we're going to be integrating the orange function minus the green function. From here to here, we're going to be integrating the pinkish purplish function minus the green function. So we're going to do 2 separate integrals, one here, and it's going to have different integrands in the 2 cases. But before we actually can get to doing the integration, we have to figure out where does everything intersect? What are the bounds that we should be integrating over? So we can tell certainly that's going to be 0, but now we have to say, well, what is this x value, and what is this x value? So this x value comes from when these 2 are equal, that we want to have 8 over x squared to equal 8 times x. And those 8's can cancel, and we end up with x cubed is equal to 1. So x is equal to 1. That value right there is going to be 1. Now we have to figure out when is our purple line and our green line. What is that intersection point? So purple and green, we want 8 over x squared to equal to x, which is 8 is equal to x cubed. That happens when x is equal to 2. So we see here, we're going to be integrating the orange function minus the green function between 0 and 1, and we're going to be integrating the purple function minus the green function between 1 and 2. So at this point then, what do we have here? We're integrating from 0 to 1 of the orange function minus the green function, so that's 8x minus x. And then from 1 to 2, we're integrating the purple function minus the green function, so that's 8 over x squared minus x. And 8 over x squared, that's 8 times x to the minus 2. So these are the integrals that we have to calculate here. Now, note that 8x minus x, that's just 7x. So we're integrating, so the integral of 7x is 7/2 x squared. Plug in 0 and 1. And then over here, we have 8x to the minus 2. So that's going to be minus 8x to the minus 1 minus x squared over 2. Plug in 1 and 2 there. And so our answers here, this gives us 7/2 after we plug in everything. This gives us 5/2. And so our overall answer is 7/2 plus 5/2 is equal to 6. So this problem, let's just kind of recap here. What were the key points of this problem? We have to draw the picture first. We really don't stand a chance of getting this problem right if we don't draw a picture. Then we have to find the different intersection points in order to figure out where to run our bounds between, because we weren't given the bounds there. And we have to chop it appropriately because we're going to be integrating different differences of functions on the different intervals, I should say.